Today we're going to talk about advanced rationalizing, which is going to ask the question of what do we do when we have a square root in the denominator and it's not that basic case from the previous video. So before we get into that, you might be wondering, this looks kind of crazy and intense. When does this come up? Why are we doing this in the first place? There's a lot of reasons, so I'm just going to mention one, which is it comes up a lot in geometry, specifically when you're doing the Pythagorean theorem. We haven't done that yet, but stay tuned for future videos. When you'll see when we do that, you'll have to have this skill in place. So for now, just assume this is a skill you should have. All right, so this says versus because this is the basic rationalizing case where you have some sort of square root in the denominator, and these two are examples of advanced rationalizing where the bottom has more than one term. There's the 3 root 5, but then there's a plus 7. There's this, but then there's also something else. So let's try to do our basic rationalizing technique, which is to remind you, just multiply by root 5 over root 5, which this will undo this square root. It'll introduce it on the top, but we don't care that that happens. So this will solve our basic rationalizing problem. Let's see what happens when we try to do this in the advanced case. So we say, okay, we see our square root of 5, let's multiply by its square root of 5. So what this will do is it will destroy this square root because this will just get us a 5, but it will introduce it over here. So think of it like a leaky boat. We fixed one leak, but we've introduced another leak. So the basic approach will not work on this problem. So we need a more advanced thing to multiply by in order to get rid of the square root. And not to mention, there could be 2 square roots, so then what do you multiply by, the 5 or the 3? So this basic approach won't work for these problems. So here, in short, is the magic thing you want to do. You want to take whatever you see here and flip this sign. So again, it's the numerator and denominator are the same because we want to multiply by 1, so we don't change the value. Now there's a technical term, this is the conjugate. That doesn't matter, but in case you see it, when you refer to the minus instead of the plus or the plus instead of the minus, that'll be taking the conjugate of this number. So I might refer to it as taking the conjugate. So what's so magical about this thing? Well, on the top, we're just going to get 6 root 5 minus 14. So that part's not very exciting. But on the bottom, we're going to get 1, 2, 3, 4. We're going to get all these interactions. And if you remember from one of the previous videos, I believe it's part 2 on the operations, let's just do this problem by itself. So the 3 root 5 times the 3 root 5 is just 9 times 5. The square roots cancel. So that's 1. Then we're going to do this one, 2, 3, 4. This is going to be a negative 21 root 5. This is going to be a positive 21 root 5. And this is going to get us negative 49. So 45 minus 49 is negative 4. And this is a negative and positive same number, so these cancel. So the reason we picked this to be minus is that this will always work out such that this cancels this. And that's the whole purpose, because we've sort of squared the square roots, but we didn't introduce any new square roots. So let's try an example with this. Let's try another example. So let's say 2 over 3 root 2. Okay, so whatever we have here, we copy it over, but we flip the sign. All right, so the top is pretty straightforward. It's going to be 6 root 2, that's this part, and then that part's 8 root 3. Now the bottom part, this times this is going to be 9 times 2. That's going to give us a positive 12 root 6, but these two are going to give us a negative 12 root 6, which is why we picked this in the first place. So that's gone. And then these two are going to give us minus 16 times 3. So notice all the square roots basically got squared without introducing new square roots. Had we just copied this and made this a minus, I'll show you in a second what would have happened. So you can evaluate this. Notice there's no square roots in the denominator. So let's try doing the minus. So if we had done the minus, I don't even care about the top, let's just focus on the bottom. So on the bottom we'll still get 9 times 2. Then we'll have minus 12 root 6 from these two. But then we'll get another 12 root 6 plus 16 times 3. So the point is, these two have square roots and they did not cancel. They're going to accumulate and give us negative 24 root 6. The point is, whatever we did not kill off all the square roots. We want all the square roots gone, which is why we pick a minus with a plus. If it's a plus, you pick the minus. All right.